Fundamentals of computing 1. Topic 1, data structures and abstract data types. So basically, data structures are things which are used to be able to contain information. So like computers kind of use them as containers, and there are multiple of them, and in which different kinds of information is stored. For example, in this one, char, in this one, int, this one, string, and in this one, boolean. So basically these are all data structures which better suit different conditions. There's also, let's just put in the other one, so there's double or float. So double slash float. So there's the next one. So say there are different events in which these work. So the input C, the input lol, the input 7, the input 7.7, and the input true. So these all have a specific place, which is where data structure comes in. So these are data types. So obviously the character would be C, the integer would be 7 because it's a whole number, the string would be lol, boolean would be true, and the double or float, which is a decimal number, would be 7.7. Simple. So when storing data, the programmer must decide which data structure they would want to use. So whatever's best suited for the environment they're working in. So one important thing you need to know about is arrays. So an array is a indexed set of related elements. So indexed means like ordered, so from some to some, and then it's in a list. And from being in a list, it's ordered and is kept with things such as itself, such as names or dates. These would all be arrays, and inside arrays the main parts are that they are relative topic, so they are relatively close to one another. They are finite, so like the array won't go on forever, is assumed, and they have the same data type. So those are the three basics of an array. Arrays must be relevant to the topic, must be finite, and must all have the same data type. For example, the array, and then say you had the array names, and then you would store the arrays, so Sam, Rob, Dave, sure. So this is an array. This is a good array because obviously the main parts are kept relatively together. So it is a clear name. All the values are relevant. There is an end to it, so it is finite. And they are all strings, so they all have the same data type or data structure. Thus, that is the use of an array. And let's not get rid of it yet. So, in regards to coding in arrays, if you were to use these, actually, yeah, we do get rid of this, but remember the names, they work like this. So, in positions and the thing, so array start counting from 0, so 0, 1, 2, and then the thing was Sam, Rob or Bob, whatever I called it, and then Dave. So although Dave is theoretically in the third category, it is in the second place in the variable, thus is given the place 2. The index values always start from 0. So from this, if you were to try and retrieve stuff such as my array dot get and then thing, it would thing2, it would obviously return Dave, because Dave is the thing in position 2 of my array. So there are other things you can do with arrays. You can obviously have an array, and inside that array you can have another array. So this one has 1, 2, and then 3 declared inside this array, and then in another array it would have 1, 7, 11 declared. So these two types of arrays obviously are inside the same array. So when you were to retrieve this, it works as any normal array. This part would be the 0 value, and this part would be 1, so in index form, and then you go into subsection, so this would be 0, this would be 1, and this would be 2. That would be the same for this group of values. So when you were to retrieve it, you would obviously be like, let's just call this lol, and it would be lol 0, 2. So if we were trying to get position 0 and 2, it'd be in array 0, which would be this one, then it'd be position 2, which would be this. So it would return 3. Simple. Arrays covered. Bit of genius that was. And now, files. So this is another important part of data structures and organization. So files are used to be able to store information. So here's my beautiful file. There you go, that's a bit of paper coming out of it. And sure, file. So files are used to be able to store information, as well as series of files. So one file could be like a super file, which would be declared something like maths, and then inside this file there would be smaller files with stuff such as, per se, year 1 and year 2, and inside this there would be programs and saved Word documents, etc. So each file is made up of records which are composed of numbers of fields. It's very important that when you are programming that you have files that you can read and write to, but these make it easier to be able to store stuff previously before actually running the program, thus making it a lot easier on yourself. Yes.